I definitely rewrote the y prime as dy dx. You can't really separate it unless you look at it written in that notation. I have two terms that both have a dy dx in it, so I factored out the dy dx and then separated my variables. So kind of looking at what happens, multiplying both sides by dx, and I basically divided by the 2x plus 9, and then I divided both sides by y. I'm going to solve it out using the example I have in red. To be clear though, a different route you could have taken is instead of dividing both sides by y, you could have divided both sides by negative y, which I have written down in the lime green. It will adjust, like pretty much all your signs will end up being opposite, but like the steps in the algebra is still going to be the same. So solving this, we know that after separating our variables, we both basically are going to integrate both sides. 1 over y is the natural log of the absolute value of y, which is equal to integrating this negative 1 over 2x plus 9. What integration method do I also need to be sure I use for that one? U sub, right? So if you're looking at the denominator, that denominator is 2x plus 9, so that will be your u. U prime would then be 2, so your coefficient would then become negative 1/2, the natural log of the absolute value of 2x plus 9 plus c. So that is what we would call the general solution. So we separated and then we found the integral. Again, if you had gotten your negative on the other side, then pretty much all your signs would have been different. Of course, still a plus c. Do want to be clear, I technically could have dropped the absolute value when I integrated. Why did I know I could eventually drop the absolute value? They're both greater than 0. So it tells you that x is greater than 0 and y is greater than 0. So you could have dropped the absolute value, which I am going to do kind of on the next step. But looking at this, I am going to go ahead and solve for that initial condition of c. Again, you do have two options. There's always lots of options you can take. You can either solve for y and then plug in the initial condition, or plug in the initial condition and then solve for y. I personally like solving for c before doing a lot more algebra. So it tells me that y of 0 is equal to 1. So when y is 1, we know that x is 0. The natural log of 1 is 0, so I get c is equal to 1/2 on the natural log of 9. If you had written yours the way that I have the lime green, then your c would have been just negative 1/2 the natural log of 9, so just the opposite sign. I would probably leave my c like that, but again, we know there's often different ways we can write answers. Technically, that coefficient could be moved up as an exponent, so the natural log of 9 to the 1/2 is perfectly fine, which is of course saying the same thing as the natural log of 3. So all those answers would have been equivalent. And so I'm going to go ahead and plug that back in and then solve for y. I am dropping the absolute value now just because I know that y is positive and x is always positive. And my c, I'm just going to go ahead and use the ugly version of it, 1/2 natural log of 9. That is the particular solution. If it didn't ask me to solve for y, then I could leave my answer like that. This one, though, is asking me to solve for y, so in order to receive full credit, I would want to make sure I solve for y. Algebraically, what would you need to do to both sides to solve for y? Base e, right? So we are going to base e, and when we base e, everything we see is going to kind of go into the exponent. So on that left-hand side, I just have y. On that right-hand side, I have e to the negative 1/2 of the natural log of 2x plus 9 plus 1/2 natural log of 9. All of that we see is in the exponent, and that would be our final answer. Y is equal to all of that. Questions on my steps or the algebra in that problem?
Mr. Brown?
Yeah, so Ben asked the question, can you simplify that bottom part? What bottom part am I looking at?
Or like the answer.
We are going to simplify the answer when we get there. Who else was on? Matthew, go ahead.
Yeah, I was going to ask if the e would cancel out the natural logs.
Okay, so let's go ahead. Y'all really want to simplify it, so we'll go ahead and simplify it. On the AP exam, if this was multiple choice, like just to be super clear, that will not be one of the answers, like that, they just would never leave an answer written that way. Yes, you are correct if you're thinking that I see some natural log, I see an E, I know they should cancel out, you just want to make sure you do the algebra correctly so that they do cancel out. And that's really why I chose this problem to look at. I'm just going to go over to the next slide so I have kind of a fresh screen to deal with. That's where I'm going to kind of finish up this problem. Not really the calculus, but like the algebra of simplifying it. Do need to know how to simplify it, but of course you also do need to know how to simplify it correctly. So if I'm looking at this problem and if I am trying to solve it, we know in math, like if I see the e, let me get a pen that works. If I have like e to the natural log of a whole bunch of junk, then what's going to be left over is just all that junk. Works the same way as well. If I have the natural log of e to a bunch of junk, then what's going to be left over is basically all the junk. Like we know that those are inverses and they cancel each other out. But looking at how this problem is written right now, we can't just like jump straight into just like canceling out the e's and the natural log. What we are going to have to do is look at this exponent, simplify this exponent first, and then use that to kind of simplify it. So I'm going to go off to the side. Here's my exponent, -1/2 natural log of 2x plus 9 plus 1/2 natural log of 9. Let's find ways to simplify it. I do see I have two natural logs. They are being added together. I know that when natural logs are added, I can combine them with multiplication. Right now I can't do that though because we do have those coefficients out in front. Two options, you either factor them out or kind of move them into exponents. Since they are different, I'm going to go ahead and move them up as an exponent. This becomes the natural log of 2x plus 9 to the -1/2 plus the natural log of 9 to the 1/2. So again, property of exponents, coefficients turn into exponents, or exponents can come down as coefficients. And then I see that we are adding these. When we are adding two logarithms, then we can combine them using the product rule for logarithms as multiplication. So I have the natural log of 2x plus 9 to the -1/2 times 9 to the 1/2, which is just 3. But now we've taken this exponent from complicated exponent to slightly more simple exponent. So I'm going to go back into the problem and rewrite it. So my function y is equal to e. What is that simplified exponent? The natural log of 2x plus 9 to the -1/2 times, I'm going to go ahead and simplify this, 9 to the 1/2 is 3. Now we do see e raised to the natural log. What's going to happen to the e and the natural log? They cancel. So you have y is just equal to the 2x plus 9 to the -1/2 times 3. Or y is equal to 3 over the square root of 2x plus 9. On the AP exam, pretty much guaranteed, this is how they would write the y, not like that. Yes, Seth?
Can you split up the exponent into 2 base e?
So yes, so Seth asked the question if you can split it up differently, and so yes, I did just do it. That's just one way, where I use kind of like properties of logarithms to simplify it. I could have, and I'll work it out too, because I think it's good to see different ways. We could use properties of exponents. And properties of exponent states that when you are adding in the exponent, that's like the same thing as multiplying. So you could have written it this way. And then it's going to be kind of a similar process. So then those coefficients would move up into the exponent. So I have e to the natural log 2x plus 9 to the -1/2 times e to the natural log of 3. E and the natural logs are touching each other, so they would cancel out, and you'll end up with the same answer. So kind of like two paths. One's using properties of logarithms, the other one's using properties of exponents, but you're still going to end up with the same answer. So again, that's like not really the calculus part, but you still want to make sure you have those algebra skills when it comes to simplifying these problems, especially because we are going to run into a lot of differential equations that end up with logarithms and exponentials, and you're just going to need to know how to simplify those because they do show up fairly often. Questions on that? All right, so what I want you working on today, that's it for like the notes portion of class. Your quiz is on Thursday, so I mainly want you to continue working on homeworks number 1, homework number 2, and then homeworks number 3. Remember on homework 3, you do not need to solve for y unless you're looking at your general solution and you honestly don't think you would be able to solve for y pretty easily. I'm going to go tell you to go ahead and try it. So I'm going to let today mainly be a work day for the rest of the period. Tomorrow is a review day, and I do have something planned. Maybe you finish your homework and so you want to go ahead and do it. But if you're looking in your OneNote, you might have to resync it because I just shared it during my planning during second period. At the very bottom, I have a quiz day review where I basically put like an AP question, and that will kind of show you what you need to be able to do for your quiz on Thursday. It'll be like an example of one page where you have one function and then kind of like 4 related parts to that question. But that's what we're going to do tomorrow. Today, I would rather you kind of focus on getting all of your homework done. So that is what I'm going to ask you to do for the remainder of the period. I am here to answer questions, so especially if you're at home or here in person, get my attention to ask questions. Use this time to finish up homework, and then that way tomorrow we can kind of review all these topics mixed together, and then you're quizzing on Thursday. After the quiz, we have 2 more topics to cover in this unit, which is going to be the word problem differential equations. So we have to do the proportionality ones, and then we also have to do logistic growth. And then remember, your test for this unit is going to be on Friday, March 5th, so pretty much next week. So I'll go ahead and get started on that homework, continue working on that homework, and then we'll regroup tomorrow to review. And again, if you have questions, definitely get my attention so that I can answer those